one's not in the book, but it's one like you'll see where you need to reduce. Two over 6. Now with these smaller numbers, it's pretty much, you just look at, you have factors of 2 and you have factors of 6. Now if you have to, you can break this down, in this case, into 2 times 1 over 6 can be broken down into 1 times 2 times 3, right? Every number is divisible by 1. Okay, and so we can look at this and say, all right, 2 can divide into itself. And so that would be 1 for each of those. So we can say that, now we just multiply 1 times 1, that'll be 1. And then 1 times 3 is 3. So 2 over 6 reduces to 1/3. Okay, and this is really important, more so as you get further along in your math courses, in that sometimes fractions can be so large, excuse me, that they can be difficult to work with, but if you reduce them, then they become more manageable and more practical to work through a problem. So if we have something like problem 73, where we have 4 over 24. Okay, 4, that can be broken down into 1 times what? Yeah, 1 times 4, and we can break 4 down into 2 times 2, right? And 24, that can be broken down into, well, 2 can divide into 24 how many times? 12, right? And 12, that can be broken down even further, right? 12 can be broken down into 4 times 3, and 4, that can be broken down into 2 times 2. So what you have here is 1 times 2 times 2 for 4, and here you have 1 times 2, and then times 2 times 2 times 3. If you wanted to break it down into its prime factors.
Why do you pick 2 for the 24?
Well, you can pick any number of different factors. For these first 2, I just wanted to break them down into what we call the prime factors, and then after that you can just break them down into just smaller numbers. But I just wanted to show you at first that you can break them down into your prime factors if you had to. Okay, so we know that these 2's can cancel out and they go to 1. These 2 cancel out, they go to 1. So we end up with 1, right? Because this is like saying 1 times 1 times 1 is 1 over what we have in the denominator? 2? Yeah, 1 over 6. So another way that you could have reduced this fraction is you could have said 4 over 24, and then just break down the 24 into factors, 2 factors, such as, what would 2 numbers times 24 give you? Okay, 12 and 2. Well, we know that this time I'm not going to break them down into the prime factors. You know that you can divide 4 into 12, right? And what do we get there? 3. 4 divides into itself once, 1. And so now what we have here is we've got 1 over 3 times 2 is 6. So you could break down the numbers into a lot of different combinations and still make it easier to get your reduced fraction. Okay? All right, any questions with that? All right, well, let's say we have 9 over 25. Okay, well 9, that breaks down into what? Yeah, 3 times 3 And how about 25? 5 times 5, right. Can you cancel anything there? No, you can't. So 9 over 25 is, it's already in its most reduced state. Okay? So your answer would be the same as what you started with, because you can't reduce it anymore. Alright? So there's a couple of problems like that on the homework. Okay, how about 24 over 24? 1, right. You can, 24 can divide into 24 once. 24 goes into itself once. You get 1 over 1, it's just 1. Okay? Alright, here we have 12 over 30. Okay, so let's try to break down these numbers into at least two factors for each one. What are some numbers that multiply to give us 12? 6 and 2. So that'd be 6 times 2. And how about 30? 5 times 6. So right away we can see that the 6's cancel, right? And so we end up with what for a simplified 2 over 5, right? 2/5.
I'm confused, why do you cancel the 6?
Well, because 6's divide into each other. It's like 24 over 24 is 1. 6, if you had, because what you're doing here is division. 12, this is like 12 over 30, that's like saying 12 divided by 30. So this would be like saying 6 divided by 6.
Okay.
Okay, or if you said 6 over 6 like this. Okay, so in other words, we could have broken this fraction up into 6 over 6 times 2 over 5, and see, that gives you the same thing.
Yeah, for the homework, we had to show that, like the multiplication, how you broke it down. Like usually, if that was me, I was like put the 6 beside the 12 and 6 beside the 30. You just come up with the same thing, but like it's just a lot less.
How do you put this?
Like just like okay, I wouldn't be doing the I wouldn't show the
He
work.
wouldn't do the
right there.
multiplication, he'd do it by division.
Yeah.
I did one way.
Yeah, you could say, all right, what you're saying here is, here you have, here's 12 over 30. And you said, what you're saying is, okay, I know 6 goes into 12 2 times, and 6 goes into 30 5 times, like that, right?
Yeah.
And then put 2 over 5, yeah. As long as you show me, you know, something, that'd be fine. All right. Anything else? It's just that with higher numbers, the higher you get, it gets harder to figure out what goes into both. So breaking them down into factors, or numbers multiplied, to give you that 12 in this case, you know, that can be another option for you. Okay?
Did you do 75?
Well, I'm going to do 70.
Oh, wait a minute,
Yeah. I'm going to do problem 76 next. No, I did that one. That was 76 was this one here. On problem 75. It's on the next page. Yeah, that one is similar to what I did on 76. Yeah. Okay,